Hey guys, it's Paulo Haddad, and in this video we are going to finish our description of the summary we have in OpenDSS. So let's go to the computer. What I showed you in the last video was how to run all the file. So in this case, what we did until here, we loaded the model. Okay, lines, transformers, loads, capacitors. We saw that we have two guys here, and one of those, the calc voltage, performs a direct power flow. Let's do that. And then we set a snapshot mode, and then we can solve it. So when we do that, as you can see, we have a status here in the summary, solved. It's good news. The mode we used was snap. There is this number here that we are going to see it changing when we use daily mode. The load multiply it's 1. Later in another video I'll show you how we can change it. Devices 38, buses 16, and nodes 41. Remember that we need a power flow because OpenDSS builds the Y matrix, and when it does that, it then have the information of 16 and 41 for buses and nodes. We are with control mode static. I'm not gonna focus on that right now. Basically, we have different types of control modes, and the most famous ones is static and time. For snapshot, static is the one we should use. I'm not really sure if time will change anything on the simulation. I can check that later, but anyway, here for us is static. And then we have three different things here: total iterations, control iterations, and max solution iteration. So to understand those three numbers, we need to see a diagram that shows the simulation process that OpenDSS does. So to do that, with me here, go to your OpenDSS folder, go to examples, then you go to Python, and here in Python, go to Python to OpenDSS control interface. This is Adam wrote this for us, very helpful. And if you go below here, you're gonna see this figure. Okay, and what I'm gonna emphasize here, we have a out loop here, which is for time series type of simulation, but I'm gonna just focus on one point in time. So I'm gonna look just for those blue boxes. So first thing, OpenDSS starts a solution. Probably is not doing that in a snapshot mode. It goes directly to a power flow. So first, OpenDSS performs a power flow. And as you know, if you remember the methods that you probably have seen in your power system courses like Newton-Raphson or Gauss, you always have iterations. Same thing applies here for the method OpenDSS uses, which are not the ones I mentioned, but we need to interact, right? We change the voltage, we change the compensation current of the generator and loads, then we perform a power flow, we get a new a set of voltages. With this new set of voltage, we then change the currents, and you do that until the voltages between two iterations are so close to each other, then you say, well, that's the voltage that makes sense. Okay, cool. So let's say you take here 4 iterations to converge. And then when you do that, you go to this box in which the control elements that we have in OpenDSS will check if they need to operate to satisfy any condition. For instance, let's focus on regulators. Let's say that from your power flow solution, you got the voltage that the regulator is monitoring outside the desired range of the regulator. We can talk about regulator in the future. I'm not gonna get in details here, but let's say that the voltage is outside of the desired range of the regulator. Okay, what the regulator is gonna do in this point, he's going to change the tap to try to make the voltage, and ends up in the range. So when you change the tap, OpenDSS will then change the matrix, the Y matrix, and perform a new power flow. Well, with the new power flow, you get a new set of voltages, and then the regulator that was there will ask again, this voltage that I'm monitoring, it's outside the range that I want. If that's true, the regulator again will change the tap, which will impact the Y matrix, which will need a new power flow, and then you will get a new set of voltages. Now, with this third one, if the regulator sees that the voltage that he's monitoring, it's inside the range, he doesn't do anything. So, and then you finish your simulation process. You see that in this case, we performed 3 times the power flow. Each power flow has a number of iterations to converge. And these 3 power flows are, in another way, these 3 times that the regulator asked about the voltage he's interested in, I call that control loop. So we did 1 control loop, 1 power flow, control loop, power flow again for the second control loop, and power flow again for the third control loop. So when you come back to OpenDSS, and you see here, we took 3 control loops. So the regulators, or the regulator in my example there, will ask it 3 times. And the third time when he asked it, the voltage was inside the desired range. And all right, finish the simulation process. You see here max solution iteration. So it means that one of the 3 power flows we did, one of those took 4 iterations, okay? And when you see total iterations equals 11, it means that we are summing here, we are combining all the iterations for the 3 power flows. Let's say the first one took 4 iterations, the second one took 3 iterations, and the last one took 4 iterations. So it ends up having 11 iterations of power flow. However, we had 3 power flows. So, let's say 4 for 3 or something like that. One thing that I want to just show you here really quickly, I am not expecting you to understand here, is just to give you an insight. If you go to show and you go to event log, you're going to see here, guys, don't worry, I'm going to talk about them later. So you see in your control iteration 1, you changed the tap of your regulators to that. So, and for your second control iteration, you changed the regulators to a different tap. For the third, didn't need to change anything because it was inside the range. Okay, awesome. So very important. One thing though we can do, we say we can do it like that. Set control mode, and you see here that we are using static. OpenDSS again has that as default, but I can say off. I say I'm not gonna allow the regulator ask anything. They are not operating. The way we have the first power flow, that's the way we are going to finish our simulation. And then if I run everything here, Control A, and then right click, Control D, or just Control D, you see that we have here a control iterations number 1. Why? Because they didn't ask, just 1 power flow and the simulation was done. However, it took 3 iterations to solve the power flow, and it's equal to the total iterations because we just had one control iteration. So if I come back here, take this off, okay, and run OpenDSS again, or better than off, let's, we are learning here. I know OpenDSS uses default, but we are learning funny static, right? We run that, and you see 11.4. So I just saw that when you perform just the power flow, the first power flow, this is the same when we are doing here, the first control iteration is the same. We was with 3, and then we end up with 11, right? And the max was 4. So if I know that the first power flow took 3 iterations, the max solution iteration was 4, so 3, 4, 7, and the other also has 4 iterations. So the first power flow 3 iterations, the second 4, the third 4, and then we have a total of 11. I know, guys, this is maybe a lot of information here to share with you, but I think those are really important foundations of OpenDSS. We are going to get into more fun stuff, looking at voltage, plotting, circuit, profile, all those things. But I really think that the foundation and be able to really see those results and understand are very helpful, and it's very it's very important for us to move forward with these two. For the next video, then I'm gonna talk about a little bit of the circuit summary results, right? So we have here, and then we're gonna move to other stuff like show voltage, show currents, powers, and so on. So stay with me. This is just the beginning. We need to have a good foundation, and that's what we are doing here. Again, guys, before you leave this video, don't forget to give me the thumbs up. Don't forget to subscribe to my channel, hit the bell button, and I hope to see you in the next video.